Hello, friends. Now we shall discuss about overhead transmission lines. Okay. Uh, you know that electric power can be transmitted or distributed either by means of overhead transmission lines or by underground cables also. But the reason we are not adopting underground cables for the transmission of electrical power because of two main reasons. First one is the installation cost of underground cables is very high. Okay. And the second reason is for economical reason we are transmitting the electrical power at very high voltages. And if the voltage level is increased, we need to provide suitable insulation for that. For underground cables, we have to provide an additional insulation. But as the voltage level is very high, we cannot afford to provide such a huge insulation. So for these reasons, we are not using underground cables for the transmission of electrical power. And nowadays, because of the advancements in the technology, we are using underground cables for the transmission of electrical power for a short distance, not for a longer distance. Because as the length of the cable increases, the resistance also increases. Okay, so. For this reason, we are using only overhead lines for a long distance. Okay. An overhead line is subjected to uncertain weather conditions and other external interferences. So therefore, we have to use a proper mechanical factors so as to ensure the continuity of the operation of the line. In general, we are talking. The line should be such as to provide a support against a worst weather conditions. So we shall discuss and we shall focus our attention on the aspects of the mechanical design of overhead transmission lines. Okay. Now, let us see what are the main components of overhead lines. Okay. An overhead line may be used to transmit or distribute the electrical power. The successful operation of an overhead line always depends upon the mechanical design of the transmission line. While constructing an overhead line, it should be ensured that mechanical strength of the line is such as to provide a support against the most probable weather conditions. It should withstand the worst weather conditions. Weather conditions, it may be wind pressure, it may be ice. Okay, so under such weather conditions, that your transmission line should withstand all these pressures. In general, the main components of the overhead transmission lines are, first one is supports. These supports may be poles or towers. What they will do, they will support the line conductors and they will keep these towers or poles, keep the conductors at a suitable level above the ground. This is the first component. Second one is the conductors. These conductors carry electrical power and they carry the electrical power from the sending end, or you can say, what is that sending end? The power stations to the receiving end station, or you can till where, to the your consumers. And the third main component of our transmission line is the insulators. The transmission, the power, electric power is transmitted at very high voltage and we need to insulate them. Otherwise what will happen? There will be a short circuit between the tower and the transmission line. So we have to provide an insulation between the conductor and the tower. So we are using insulators. So insulators, these are attached to the supports and insulate the conductors from the ground. Okay. Along with this, we have a cross arms also. Okay. These cross arms will provide supports to the insulators. Okay. Then miscellaneous items like phase plates, danger plates, lightning arrestor, anti-ground wires. All these are also a part of components of the overhead transmission line. The continuity of operation in the overhead transmission line depends upon the judicious choice of what you can say is all these above components what we have discussed. It all depends upon the judicious choice of all these components. Therefore, it is very very essential to have a detailed discussion about each one of them. Okay, we'll see one by one. Okay, let us see about the line supports. The supporting structures for overhead transmission line conductors are of various types. Okay, like they are also called as poles, towers. Okay, in general, the line supports should have these following properties. Okay, what are those? Let us say one by one. Okay. First one, high mechanical strength. Okay, high mechanical strength to withstand the weight of the conductors and wind loads, ice loads, etc. Second one is light in weight. The weight should be less without the loss of mechanical strength. Okay, you should understand that. You should not compromise with the mechanical strength, but weight of the support should be light. Next one is, third point is about it should be cheap in cost, or you can say the cost should be low and economical to maintain. It should have a longer life. Okay, and it should be easily accessible. Okay, easy accessibility of conductors for maintenance. Okay, you should be able to reach out to the conductors for the maintenance. Okay, all these. There are so many types of structures we are using: wooden poles, steel poles, RCC poles, and lattice. This is also a type of a pole. The choice of supporting structure for a particular case, it depends on the span. Span in the sense the distance between the two supports, that is a span. Okay, and it also depends on the cross sectional area. It depends upon the line voltage. Of course, it also depends upon the cost. Okay, these are all the factors that decides which type of line support we need to use. Okay, so we'll see in the next video lecture what are all the types of line supports we employ for the transmission and distribution purpose. Okay, thank you.